Hi, today I want to explain to you a couple of ideas that usually students take time or there's a little bit of a learning curve to get used to them. So this is about the reduced echelon form and the way that you're going to use it. So typically what you do is you start with a system of equations, then out of that you look at the coefficients, create an augmented matrix like this one that they're telling you here, and then the idea is that we're going to use the basic row operations um, to reduce the matrix. And once that we do that once that we reduce it to the echelon form, we are going to be able to figure out the solutions of the system of equations. So we get our reduced matrix and then we go and read it. That gives us a reduced system of equations. And once that we have a reduced system of equations, we can see what are the solutions. So I want to give you an example, a very specific example on that. But before doing that, let me explain to you what does it mean to have a reduced echelon form. So what we're going to do is, and you have here the definition formally, so please go ahead and read it on your own. I'm just going to give you a few ideas for you, so when you read it, hopefully it will make more sense to you. So ideally, what we would like to do is we would like to have here a matrix that in the diagonal has just ones and zeros everywhere else. But that is not always possible depending on the matrix that you have. So for example, it could be that you have a 1 here, zeros here, a 1 in the entry 2, 2, and zeros everywhere else, but then you get a 0 here. And that means that with this 0 here, you cannot go and transform these using our row operations. So it means that once that you get to this 0, and once that you have 1 and zeros everywhere else, 1 and zeros everywhere else, then you would be done, and this would be also in this echelon form, the so-called echelon form. What is another possible scenario? So you have a 1 here, and when you're trying to have a 1 here, you end up having zeros here. So if you have zeros here, there is nothing to do with our row operations to get a 1 here. So you are just going to move from this position to this position right here. And then you want a 1 here, zeros here, and then you continue moving. So let me just show you this other situation here. So for example, here you have your 1, you have 0, so that means that you cannot do anything. Sorry, here you have 1, you have 0, and then you move over and you have a 1 and zeros. But it could be that if you move over, you have again zeros, then you just continue moving over to see if you can get a 1 until the end. The other possible scenario is you don't have a 1 here because this whole column gives you zeros. So what you do is you again move over and then start a new diagonal here. So you have a 1 here. Your goal would be to make zeros here. And once that you have that, you move to the next position in the new diagonal. And so you have a 1 here, and you want to create zeros in that column, and so on. So you can see that they're using that logic, you might have these other two scenarios. So all of these correspond to reduced echelon forms. So let me just go over this example. So in this example, I have a 1 here, and I already have zeros here. So I try to move over here, and if you see, these and these entries are zeros already, so there is no way that I can just get a 1 here. So that's fine. I move over, and then I want a 1 here, which I have. And with this one, you could, if it's not done already, make these two entries 0. And then, so this is good. And then I go again in the diagonal. So this would be my new entry. I ideally would want a 1, but I have a 0. And I cannot change anything else, because if I try to change here, you see these are already, like I have a 1 here and I have a 1 here. So that wouldn't be helping me. So that means that I stop here. I try to move over, but there's a 0 here. So I stop, and that means that this is already reduced in the echelon form. So that's a key idea of the echelon form. And what I'm going to do in the next video is that I'm going to explain to you a specific example that illustrates all of these ideas. Hello. In this video, what we're going to do is I'm going to go over this example to illustrate the ideas of how you can use the reduced echelon form to figure out the solutions for a system of equations. So I just want you to know that this is going to be, my explanations are going to be related to section 1.5.3 in your textbook, example 4. So we'll go to the board and I'll explain to you this. Okay, so this is an example on the connection between the systems of equations, solving a system of equations, and the technique of reduced echelon form. So I start with this system of equations. It's a system of equations on 4 variables, even though you can tell here that x2 doesn't show up there. So what we do is we take the coefficients and we form this augmented matrix. So typically, we put a line here. This time I'm not going to continue writing the line, but it's for you to just connect these ideas with what we have in the textbook. These are the coefficients corresponding to the variable x1, these to the x2, and again, these are zeros because there are no x2s shown up here, x3, and the coefficients for x4, and the last one is for the constants that are in this side of your equation. Okay, so what I want to do is I want to try to convert this into my reduced echelon form. And remember that what we said is, ideally I would like to have a 1 here. I don't have it. So one option could be like, oh, I divide by 5. But we don't need to do that because I already have a 1 here. So I'm going to use this 1. And what I'm going to do is I'm going to just exchange this row with this one. So that's why you will see this notation that means row 1 is exchanged with row 3. Or just switch. And if I do that, I'm going to end up with the matrix 1, 0, negative 3, negative 10, negative 7. Like I said, I'm going to omit this line. And then negative 2, 0, 7, 22, 16, 5, 0, negative 13, negative 46, negative 30, and finally 1, 0, negative 7, negative 18, and negative 11. Great. Now I have my 1 here. And what I'm going to do is I'm going to use, again, row operations to transform each of these entries that I have here into zeros. And the way to do it is what I want to do, and let me actually write it like this. So my first goal is going to be to make or transform zeros in the first column or in the remaining entries. On column 1. So remaining entries, by remaining entries, I mean these ones that are not the one that I want to keep. And this is going to be done by using this one. So the way that we're going to do this is, okay, I have my 1 here, so nothing is changing here. But for the second row, I want the 0 here. And it always takes the form of, this is the row that is row 2, I said. So this is the changing row. And then I have, I'm going to use the row with a 1, which is row 1. And I'm going to add them, but I need to multiply times a constant here that I need to determine. So if I want to make this entry 0, that means that if I multiply this times 2 and add it by this, then when I add these 2, I get a 0. So that's going to give me times a constant 2. Okay? And if I continue with the rest, you'll see. So the third entry is, my changing row is row 3, and I'm going to use row 1, and for the last one is my changing entry is row 4, and I'm going to use row 1. What are the constant here? I need to multiply times -5, so when I add it I get a 0. And here I need to multiply times -1. So when I add these two, I get a 0, which is the same, by the way, as just subtracting them, right? Okay, so what am I getting? So the first row remains the same, so that's going to give me 1, 0, -3, -10, -7. And let me just show you how to do this computation, how I would do it when I'm using my notebook. So row 2 is this one. So row 2 will be -2, 0, 7, 22, and 16. And then -5 row 1 means multiply all of these. 2 row 1 means multiply these times 2. So it's going to be 2, 0, -6, -20, and -14. And I'm going to add these two just as it says here. And what I'm getting out of this is, of course, these give me 0, 0, so 1, 2, and 2. So that means that my new entry is going to have these 0, 0, 1, 2, and 2. Now you can see in your textbook the solution to this. So I don't want to be too repetitive. Please do it on your own and check that you're getting the same that I'm getting. So after you do that, you're going to get the 0 that we want here, 0, 2, 4, and 5, and then 0, 0, -4, -8, and -4. We need to do 2 more steps similar to this. So let me tell you what we're going to do now. So we have our 1 here, and that's great. And what I was saying is, now I would like to have a 1 here, but if I see there is a 0 here, I cannot do any exchange like I did here. So to get a 1, so what I'm going to do is I'm going to move 1 over. And I have a 1 already here, and that's great. So what I'm going to do is now I am going to do row operations to transform using this 1 the rest of the entries here. So what are the row operations that we're going to require? Let's set that clear. So my row operations are going to be, remember, the row that I'm using now. So the row with a 1 is row 2. And the row that I want to change this -3 to a 0. So that's going to be in row 1. So I'm going to use row 1 plus the constant 3 times 2. So when I do this operation, I get a 0. This row remains the same, so there's nothing that is going to happen in the second row. In the third row, I'm going to have row 3. And again, I'm using my row 2 to change that. And the operation that I need to do is, I have a 1 here. If I multiply this times -2 and add it to my row 3, then that will guarantee that I get a 0. And finally, for the last row, so the row that is changing is row 4. The row that I'm using is row 2. The constant that I need to multiply is going to be +4, right? Because 4 times this will give me a 4, adding to -4, that gives me a 0. Okay, so we're going to do row 1 plus 3 row 2, and again I'm just going to show you how to do the computation for this first new row, and then I'm going to give you the answer. Make sure that you do this on your own. So row 1, do that here, is 1, 0, negative 3, negative 10, and negative 7. 3 row 2, so remember this is the one that has a 1 that we're using, is going to give me 0, 0, 3, 6, and 6. And then I'm going to add these two. So I get 1, 0. Remember, this is the component that we're trying to make 0, and you just double check that indeed you get what you want. And then negative 4, and then negative 1. So that means that my new first row is going to be 1, 0, 0, negative 4, and negative 1. The second one, we said we don't do anything, so I just copy that, 0, 0, 1, 2, 1, 2. And then if you do this operation, row 3 minus 2, row 2, that would give you 0, 0, 0, 0, 1. And then the last one, row 4 plus 4, row 2, is going to give you 0, 0, 0, 0, 4. Okay? There is one more step that I need to do to get to the reduced echelon form. If you see, let's go back. I have a 1 here. Tried to get a 1 here, but remember I couldn't. So I move over. I have a 1 here. Now I try to do the diagonal. So I go here, but again, I couldn't because there is a 0. So I move to this one. And with this one, I need to make the rest zeros. So my new row operations are going to be the following. So my row that I'm using now is going to be row 3. And the rows that I'm going to change are going to be row 1, row 2, row 3 stays the same, and then row 4. What are the coefficients that I'm going to have for row 3? So to make this one 0, I just need to add these 2, so that's going to be just 1 row 3. To make this one 0, I need to multiply this times negative 2. And to make this 0, I need to multiply row 3 times negative 4. And again, doing similar operations to this is what you would get. So you would get 1, 0, 0, negative 4, negative 1, and then basically the same, but now with zeros here, not negative 1. This got moved to 0 now. And then 0, 0, 1, 2, I got a 0 now, 0, 0, 0, 0, 1, and finally 0, 0, 0, 0, 0. Okay, great. What does this tell me? This row is not telling me anything, but if I go back and I remember that this came from a system of equations, what I've been doing with my manipulations is I've been just adding and multiplying equations times some numbers. So this still corresponds to a new set of equations that has the same system of solutions as this one. So this is going to be my coefficients for x1, coefficients for x2, and so on. And then this is my constant part, so that's the extended part. So let's read what is this telling me. This is telling me that x1 minus 4x4 should give me 0. And this second equation is telling me that x3 plus 2x4 is 0. This one is interesting. This one is actually telling us everything now. This one is telling me that 0 times anything, any of my variables, is equal to 1. And because of this, this is an inconsistency. So let me put like these signs. And that tells me that the system is inconsistent. And so there is no solution to this system. Okay, so again, there is no solution to this, but this is equivalent to this, so that means that my original system of equations has no solutions. And now you know the connection between system of equations and reduced echelon form. I hope that this helps. Thank you.